today we're going to talk about a little bit more detail about our hypothesis testing process, and then also compare our hypothesis testing process to our confidence intervals that we found back in section 7.4. Right, so in the last two sections, we performed the 4 steps of a hypothesis test and came to a conclusion about our null hypothesis. In this section, we're going to look at possible sources of error, the definitions of practical versus statistical significance, and similarities and differences between our hypothesis tests and confidence intervals. All right, so to start with, just a few reminders. Remember, as we're going through these problems, we must check our conditions. Right? We cannot use our p-value in the normal curve if we don't make sure that we have a normal distribution. So again, in some examples in the homework and things like that, we might be skipping these conditions, but do remember that we have to make sure our sample is random and independent, our sample size is large enough, and our population size is large enough. Okay. Also on this page is a reminder about our p-values. Right? A small p-value means our test statistic is extreme. Right? It means that something unusual and unexpected has occurred, which means that we reject our null hypothesis. Right? So reviewing what we've talked about in previous sections, remember that if our p-value is less than or equal to alpha, we reject our null hypothesis. And if p is greater than alpha, right, we do not reject our null hypothesis. And so as we're going through and we're making our decisions, we want to make sure that we are keeping these facts straight. All right, so down at the bottom of this page, minimizing mistakes. Right? So as we're going through and we're doing these problems, there are possibilities of making mistakes. The only way to reduce the probability of making both types of mistakes is to increase our sample size. Right? Because increasing our sample size improves the precision of the test, so we make mistakes less often. We saw that sample size played a big role in precision back in chapter 7 when we were comparing different simulations. Right? We cannot make our significance level too small. We like to use 5%, sometimes 1% or 10%, because if we make our significance level too small, we could possibly create another type of mistake as we're going through problems. All right, so there's 4 different possible outcomes when we are doing hypothesis testing. 2 of these outcomes are good. Right? So our 2 positive outcomes, our 2 correct decisions, right, would be that we determine that our null hypothesis is false, right, and we reject it. So that is one case of making a good prediction or good decision. Right? The other possibility, if our null hypothesis is true and we fail to reject it. Right? Both of those would be good, correct decisions. Our other 2 types are bad decisions. So if we reject our null hypothesis when it is true, right, that would be an incorrect decision. The probability of doing this is called our significance level. If we go back to section 8.1, we see a little bit more detail about that. Or if our null hypothesis is false and we fail to reject it, that could be another incorrect decision that we would make. All right, so at the bottom here, we're going to look at just some different mistakes that could possibly be made and discuss these a little bit more. Right, suppose a political analyst is interested in predicting whether a school bond measure on the ballot will pass. Her hypotheses are: your null hypothesis always has an equal sign, right? P equals 0.50. Our alternative hypothesis is P is greater than 0.50. Describe the 2 types of errors she might make in conducting this test. Explain what a 5% significance level means in the context of this problem. All right, so our first possible type of mistake. Right, so we have these 2 different types of mistakes that are identified, which are bad decisions that we saw in that table that was up above. Right? So one possible type of mistake is going to be to reject the null hypothesis when it is in fact true. Right? So in this scenario, this means concluding that more than 50% favor the bond. Right? So that would be rejecting the null hypothesis. Right? So if we reject the null hypothesis, we're going to say that P is greater than 50%. So we would conclude that more than 50% favor the bond. Right? Now what would make this a mistake, right? When the actual proportion is 50% or less. Right, so we conclude that it's larger when in fact it is smaller. Right? The 5% significance level means there is only a 5% chance of making this mistake. Alright, so rejecting the null hypothesis when it's true, we'd be concluding that more than 50% favor the bond when the actual proportion is less. Right. Our other mistake, right, possible bad decision, is that we fail to reject the null hypothesis when it is false. So this means concluding that 50% or less favor the bond. Right. So failing to reject the null hypothesis means that we would assume that they're the same. Right? So that means that 50% or less favor the bond when the actual proportion is more than 50%. Alright, so again, looking back up at this table, right, these two examples that we see down at the bottom, these two mistakes, right, our first one is this case of making a bad decision, our other one is this case of making a bad decision. Another type of potential mistake can be in our interpretation. Right? So even when we come to the correct conclusion, we can still make a mistake in our interpretation. Right? Because we can never be 100% certain that our conclusion is true, we must choose our language carefully. So when we are interpreting our final answer, we want to avoid using things like we have accepted or we have proved that something is true. Right? We're going to say instead, we have failed to reject. We cannot reject. We cannot conclude, something along those lines. So as you're going through and you're formulating your sentence for your final answer, just pay very careful attention to your choice of words. We don't want to say we've proved anything. Right? We're going to say either we can conclude or we cannot conclude, something along those lines. Right, there is one more pair of definitions that we're going to discuss in this section. Statistical versus practical significance. Right? A result is statistically significant when our null hypothesis is rejected. Right? However, statistically significant findings do not necessarily mean the results are useful. Right? So if we have a finding or a result that's statistically significant and it's also useful, right, then we are going to call it a practically significant result. So a couple of homework problems related to this, a possible question on the test related to this, just be comfortable with these definitions. Okay. All right, so this last example at the bottom, we're going to look at our interpretation and our idea of statistical or practical significance. In the past years, it was believed that roughly 49% of Americans had visited a library. An association of librarians wishes to know whether attendance is declining. They examined a 2013 survey in which only 48% of those in a random sample had attended a library in the last year. Using the confidence level, I should say significance level, using a significance level of 1%, they carry out a hypothesis test. The p-value is 0.0587. they send out a press release that says, "We have proved there is no decline in library attendance." So what mistakes were made? Right? So in our interpretation, right, proved is a word that we want to avoid. Right? So they have not proved that the null hypothesis is true. Right, so we don't want to use the word proved. Right? We have not proved that it is true. They have just, right, not rejected it. How can we correct them? Right? So we could say, there is not enough evidence to conclude that library membership has declined. Right. So in this case, again, going back to why our decision is to not reject our null hypothesis, right, is that our p-value is greater than alpha, right? That's what gave us the decision to not reject our null hypothesis. And instead of using the words "we have proved that it is true," right, we're going to say there is not enough evidence to conclude that it has declined. Right? Do we think that this result is statistically significant, practically significant, neither, or both? Right, so going back up to our definitions, in order to be statistically significant, the null hypothesis is rejected. Right? And if we look at this case, well, our null hypothesis was not rejected. Right? And in order to be practically significant, it also does have to be statistically significant to begin with. So in this case, we are going to say neither, right? Because the null hypothesis was not rejected. All right, the last thing that we're going to look at in this section is we're going to compare our confidence intervals from section 7.4 to our hypothesis test. When we're thinking about confidence intervals give us a way to estimate, right, what is the value of this parameter. Right? Hypothesis test, we're making a decision. Right? Are the data consistent with the parameter being one particular value, or might the parameter be something else? Right? A hypothesis test judges between two different claims. A confidence interval is making an estimate. Right? So even though they're designed to answer different questions, they are similar enough. Even what we use in StatCrunch, right? We use some similar things as far as getting into the actual problems. We're using our one proportion stats for both of these. So in particular cases, which is going to be the case in this next example, we can use confidence intervals and hypothesis tests to reach the same conclusion. Right? There's rare occasions where they might be different, but in this next example that we're going to look at, we're going to end up at the same conclusion, starting with different approaches here. There is definitely a direct correlation, relationship between our confidence levels and our significance levels. Right? They're complements of one another. Confidence level of 90% is related to a significance level of 10%, 95 to 5%, and 99 to 1%. Right, all of these being two-sided tests to make those comparisons. All right, so in this problem, in 2009, it was estimated that 63% of Americans supported the death penalty. In 2014, a Rasmussen poll found that in a random sample of 943 Americans, 538 supported the death penalty. Do we have evidence that support of the death penalty has changed amongst Americans since 2009? Right? Previously, we worked through this problem. We asked if support had declined. So in this case, we're going to do a slightly different problem. We are going to conduct a hypothesis test using a significance level of 5%. Then we're going to construct a 95% confidence level. And then we're going to explain how the two conclusions support one another. Okay, so to start with our hypothesis test, right, I'm going to do this so that way we have all of our information here. All right, so what we know, our population is all Americans. Right, our sample size is 943 Americans that were sampled. Our P-naught is 0.63, right? That's the original estimation. And our P-hat is going to be this 538 divided by 943, which gives us 0.57. Okay. All right. Our level of significance is our alpha. We were told to use a significance level of 5%. And the question that we were asked, has the proportion changed? Right? Change indicating a not equal to, so we're thinking a two-sided test. Right? So our null hypothesis, right, we're going to use our P-naught, or P sub 0 value. P equals 0.63, and our alternative hypothesis, P does not equal 0.63. We're going to skip our conditions in this particular example. Then we're going to go to StatCrunch. Again, in StatCrunch, we are going to go to our 1 proportion Z statistics, just like we do for 7.4, just like we have for the other sections. Right. Be sure to use our observed value for a number of successes. So we're going to use that 538 and that 943. Right? And then we also want to be sure when we're entering our null and our alternative hypothesis that they look exactly like this. Right? Make sure we're entering that P-naught value, that P sub 0 value for those. Okay. After we do that, we get Z is equivalent to negative 3.78, and our P value is going to be 0.0002. Right? Now we want to make a decision. We want to compare P to alpha. So P is 0.002, and that is clearly less than our significance level of 5%. Right? So P is less than alpha. Since P is less than alpha, we are going to reject our null hypothesis. Right, so that means if we reject our null hypothesis, right, we're going to cross off our null hypothesis. Right, we always have one crossed off and one circled. So that means that we're going to circle our alternative hypothesis. Okay. So our conclusion. Right, we can conclude support for the death penalty has changed since 2009. Right, so we rejected our null hypothesis, right, which means that we're going to conclude, right, that our alternative hypothesis should be the one that is most likely true. Right, so we can conclude that support for the death penalty has changed since 2009. Okay. Now we're going to do a confidence interval. Right, so our beginning kind of list of things that we know is going to be the same. Right, N is still all Americans. Our sample size is still 943 Americans sampled. Our P naught is still that original percent of 63%. Our P hat is 538 out of 943, right, or 57%. We're told to use a confidence level of 95%, right? And what we are looking for is we are looking for the confidence interval, right? And more specifically, we're looking to see, right, is P naught is our 63% in the confidence interval that we find. Again, our confidence interval is set up P hat plus or minus M, our margin of error. Now, we did some problems in section 7.4 where we worked through these every single step by hand. In this case, we're just going to use StatCrunch. So again, we're going to skip our conditions. We're going to skip finding our standard error and the margin of error. Instead, we're going to go into StatCrunch. Again, we're using our one proportion Z statistics. Right, so we're doing our proportion test, one sample with summary, right? And we're going to enter our 538 and our 943. And instead of entering all of the information for our hypothesis test, we're going to select the other button in StatCrunch that shows our confidence interval. All right, so the interval that we get, I went ahead and rounded to the nearest percent. So we get a confidence interval of 0.54 to 0.60. So we're going to say we are 95% confident that the proportion of Americans who support the death penalty is between 54% and 60%. All right, so what does this mean? What were we looking for? We were asking, is 63% inside our confidence interval? If we look at our confidence interval, well, our confidence interval has values that are lower than that. Okay. So we are going to say the confidence interval conclusion supports the hypothesis test conclusion. Because 63% is not in the confidence interval. In other words, the population proportion has changed. So, two different approaches, the same results. Right? We rejected our null hypothesis. We said that it was changed. Our value from our confidence interval was not inside, or excuse me, our population proportion that we were testing was not inside our confidence interval. So that's another way to come to the same conclusion that the population proportions have changed.